In our first video of the series where we talk about the amplitude as a component of an AC signal, and we can find the amplitude of the AC signal in the mathematical equation. Now, when we talk about the frequency, frequency is a component in a signal, especially the analog signal, and it can be defined as the number of the cycle per second, and it is measured in hertz. And you can see that the frequency talks about the time, therefore it is related to the period of a signal. If you are given the period, you can be able to find the frequency, and given the frequency, you can be able to find the period. And the period is now defined as time for one cycle, and it is given as a time. And in our previous discussion, we say the period, which is the time taken to complete one cycle. And from this waveform, we have a half cycle. This is one half of a cycle, and with this region is now the other half cycle. So when we had this positive cycle with this negative cycle, we now have a complete cycle, and the time to complete this one cycle is called the period. And the relationship can be seen by the equation. The frequency is equivalent to 1 over the period, where frequency is now 1 over the period. And with this equation and the definition, we can see that for the frequency it says per second. However, the time can be measured in terms of the period, which may not be 1 second. If we increase the period, if the period is increased, then the frequency will decrease. And we can see that the frequency is inversely proportional to the period. When the period decreases, we now have the frequency increase. Let us now look at how can we increase and decrease the frequency. The frequency itself represents the oscillation. When we talk about oscillation, that means there is a change between a positive and a negative. So imagine if we have a frequency which is unknown, and we have a period which is equals to 1 second. Then we all know that the frequency is equals to 1 over 1 second. And what does that one represent? This one now represents the frequency, which is equals to 1 cycle over 1 second. And the unit cycle over the second is equals to the hertz. Therefore, in that case, we will have the frequency is equals to 1 hertz. From the waveform, if we are to plot the waveform in terms of the signal, we can say the AC signal Vt is equals to, let's give the Vp, which is the voltage peak or the amplitude of the signal, let's say 2 sine 2 pi. Now we should have 1 hertz over t plus the phase. So what we are interested in to plot is the amplitude and the frequency. And if we plot a sinusoidal like this, if we have 1, 1, and we have 2, So 1, 2, and in terms of, let's say, volts, so it will be -1 and 2. Therefore, we know in terms of the time, it is now 0.5 second, and we have another 0.5 second. So we have the period which is equals to 1 second. So from our definition is the time taken to complete one cycle. So we have a half cycle and another half cycle. This is now the full cycle, which is the one cycle. Now the time taken to complete is 1 second. Therefore, the frequency is describing one cycle over 1 second. Let us look at what will happen to find the relationship between frequency and period when we increase the period. What will happen to the waveform? Now let's find the frequency, which is unknown, and the period we increase to 2 seconds. Therefore, we know that the frequency is equals to 1 over 2. That means 1 cycle for 2 seconds. The frequency now is 0.5 hertz. So how can we plot to see the relationship? Now we can have the waveform. Previously we said that Vt is equals to 2 sine 2 pi 0.5 t plus theta. And we say this is 2 volts and we have minus 2 volts. Now it will take us from here to here is 1 second, and from here to here is 1 second, and the total time is now 2 seconds to complete one cycle. Now we can see that when the period increases, the frequency will decrease. The frequency represents the oscillation. Therefore, by increasing the period or increase the time it takes to complete one cycle, now the frequency or the oscillation will decrease. We can summarize by increasing the period, we now decrease the frequency to a lower state, and by decreasing the period, we now have a higher state of the frequency. To fully understand what do we mean by the lower state and the higher state of the frequency, that means in the higher state we will have more oscillation, and by increasing the period we are now having less oscillation. If I now draw our previous discussion using the two plot that we discussed earlier, we can say 2 minus 2, and you can clearly see what do we mean by the more oscillation and less oscillation. In here we say the period is equals to 1. In this case we say period is equals to 2. Now we can plot. We can have 1, 2, let's say 3, and 4. We can say this one is 0.5, 1, 1.5, and 2. When we have the period is equivalent to 1, we now have a signal that is like this, where it takes only 1 second to complete the full cycle. And in the other case, where we say we increase the period to 2 seconds, now we should have a signal like this. Now let us see to have more oscillation when we have decrease in the period. That means we are talking about this graph. You will now have a graph which correspond to this. And in this case, from the first one, we can see that the frequency is equals to 2 cycle in 2 seconds. Therefore, the frequency is 1 Hz. And in the second case, where t is equals to 2, we now have the frequency which is equals to 1 cycle per 2 seconds. So in this 2 seconds, we only achieve 1 cycle. Compared to the first graph, we have 2 seconds, we achieve 2 cycles. And this cycle represents the oscillation. Therefore, what will happen? If we keep on increasing the period, that means the number of cycles will become less. And when we decrease the period, that means the cycle will become more. Therefore, we have more oscillation. Now we can see that the frequency for the second graph is 0.5 Hz. When compared to the definition of the frequency, it says number of cycles per second. That means we have a half cycle or 0.0 cycle per second. By looking at this graph, for 1 second, we have half of the cycle, which is now as 0.5. Therefore, for 1 minute, the signal covers half of the cycle. That means we can see from this graph, the half cycle is covered by 1 second. This represents this half cycle covered in 1 second. So half cycle per minute. If we continue to decrease the period, the signal now will become so small in terms of the oscillation. That is when we decrease the period. So you can see the time taken to complete 1 cycle is very, very small. And when we compare to increasing the period, that means the waveform will be like this. If you look at your computer, you might be having the frequency around 2.5 gigahertz. So that is telling you that the computer is operating at a very high frequency. That means if you want to measure such signal, you might come up with a smaller period for it to take to complete 1 cycle. Unlike if you look at a low frequency signal, it will have more time to complete one of the cycle. By comparing the signal against the power in a high frequency signal is high, and for a low frequency signal we say the power is less. By increasing the frequency, we are increasing the power of the AC signal. When we decrease the frequency, that means we decrease the power in a signal. The study of frequency is so important in electrical engineering. When you deal with a signal that is of the nature of the AC. And when we talk about the frequency itself, frequency plays an important role in a digital system as well as in power electronics. In power electronics, you will learn the buck and the boost converter and different types of converters that mostly use the frequency as the main control of the circuit. Without the frequency, you cannot be able to control the speed in which the circuit operates. When you talk about the buck converter and the boost converter, the control is the duty cycle, and the duty cycle represents the on and the off switch. And the switch is nothing but the MOSFET, which is used to control the duty cycle to the particular MOSFET. And this duty cycle have the frequency. That means when we talk about a switch, when we have a switch and we say when the switch is on, we will have 1 as the output. When the switch is off, we will have 0 at the output. So in order to get such a frequency, we normally open and close the switch. So when we say increase in the oscillation, that means we are increasing the speed of the switch to turn from on to off. And in that case, it is now an oscillator circuit which is capable of producing a signal with a certain degree of speed. And this speed of this particular signal can be able to control other devices in an electrical circuit. Also, in the analog to digital conversion, we have the analog to digital converter which produce a binary output from the analog input signal. From there, we have the sampling frequency. The sampling frequency plays an important role in determining the future of the analog signal. Because when we convert to a digital, at the end of the day, we want to reproduce this analog signal. Therefore, by choosing the right sampling frequency, we can be able to fully recover the analog signal that is being stored. And if we are not careful by increasing the period to a certain degree where the signal cannot be recovered completely, that means it does not follow the Nyquist sampling theory, where it says the frequency of the sample must be greater than or equal to 2 times the maximum frequency of the waveform. Therefore, by choosing a period which is greater and does not follow the Nyquist sampling rule, then the signal won't be reconstructed reliably. Therefore, to reconstruct the signal reliably, that means we must multiply the maximum frequency of the signal 2 times. So the speed in which the signal will be sampled will be 2 times the maximum frequency. For example, if the maximum frequency is 60 Hz, that means the switching for the sampling must be 120 Hz. So the acceptable sampling frequency must be greater than or equal to 120, 140, 1000, 10,000 and above is acceptable. But you have 110 Hz, 70 Hz, all of these signals are not acceptable. So we find the application of understanding what is a frequency can be applicable in many areas in electrical engineering. So I believe you can be fully understand what is a frequency, and later on when we dive into some of the deep problem relating to a circuit that needs the agenda of the frequency, then you can be able to relate back to this video to understand what do we mean by the frequency. The important to remember, the take-home note is that the frequency is inversely proportional to the period. By knowing this formula alone, you can be able to compute some of the most challenging tasks that deals with the frequency. And if you like our video, you can kindly subscribe to our channel and share the videos with your friends so that they can be able to learn more about what is the alternating signal. In our next video, we will discuss what is the phase of a signal.